we will now commence case study presentation from an SME, Associated Plasmatron, Mumbai, on refurbishment of an Innocenti lathe to an automated contemporary machine for business sustainability. Associated Plasmatron leveraged on innovation for business sustainability by converting a legacy machine to a contemporary equipment with benefits of cost reduction, enhanced business with less than 6 months return on investment. I now invite Mr. Vivek to take us through this case study presentation.
Hello everyone, my name is Vivek K. I am the director of Associated Plasmatron Private Limited. And I would like to thank IMTMA for giving us the opportunity to present our case study to the forum. And I would like to introduce my company. So the company was established in the year 1988 and with the aim of providing state-of-the-art thermal spray coating services. So basically thermal spray coating means we deposit a superficial layer of coating on the base substrate to increase its wear resistant properties and to increase its operational life. And we have been in this field in the last 30 years. We have 2 units, one head office based in Rabale and another plant based in Ambanath. Our Ambanath unit is certified for aerospace. And the case study that we would like to present today is about the refurbishment and automation of a conventional lathe machine to a smart machine with the view of increasing the business sustainability. This case study is presented by me. My name is Vivek K, and I'm accompanied by my team members. We have worked on this case. So basically, like you can see the image on the right, this is basically a steel mill roll. So we do coatings on the barrel area of the steel mill rollers. So the first trigger when this happened, when this idea came up, was when we had received this roller from a competitor who is based in Maharashtra. So what happened was they had bagged the project from an end user, but they were not able to really do coating on these parts because of capability constraints. So that is when they had approached to us and they had sent across this part to us for doing the coating. And this was the first time when we had actually witnessed such a big size roller. The dimension of the roller was approximately 1600 mm dia, and the length was around, say, 2 meters long. So this was the first trigger. I mean, when we actually came to know about such parts in the steel mill industry. And the second trigger then happened when we directly got an order. We directly bagged the order from JSW Steel, Bellary. Again, the size of the roller was around 1500 mm diameter and around 2 meters length. So this is when we actually got off thinking that there are such parts, such huge size parts which require coating, pre-machining and post-machining operations, and for which there are no other coating companies located in Maharashtra at least who are able to do such big size parts. Moving ahead, so these were the 2 triggers where we came out thinking about the idea of upgrading our existing machinery. So before moving forward, we did outsourcing cost analysis, taking the example of this particular roller that we received from JSW. So the job dimensions being around 1500 mm dia and 2.2 meter length. So the cost calculation that we did was, if we send this part to a vendor for pre-machining and later for post-machining, what would be the cost incurred here? So basically the cost is calculated on the basis of the area, the barrel area. So for that, we calculated the area of this roller, and the pre-machining cost being around 5 rupees per square inch and the post-machining being around 8 rupees per square inch. We were able to calculate the machining cost for this particular part. So calculating all this, the total cost of outsourcing was coming around 3.75 lakhs. So this was something on the cost incurred on per part basis that we calculated. Moving ahead, then we evaluated the market potential for these kind of parts. So what we did was we considered rollers above 750 diameter. And to get some realistic data, we contacted a person in JSW, and from him we got an idea of how many rollers are actually installed in the steel mill lines. So what information we got was there were around 120 rollers of size above 750 installed in one particular steel mill line, out of which around 50% of the rollers are coated with special materials or materials that we actually coat on the parts, like say tungsten carbide coating, chrome carbide coating, ceramic coatings. So 50% of such rollers have such kind of specialized coatings. So for calculation purpose, we considered around 10 major steel mill plants located in India. So basically, what we do is three kind of work. First is the manufacturing. So basically, these end users directly they procure the newly manufactured rolls from us. Second is the job work, which the end user does not directly procure, but it might divert the order through a OEM, like say a steel plant tech, like CMI or so. And the third case is the repair, which again the end user will directly send the roll to us, and they will ask us to remove the existing coating and redo the new coating. And the quantity I have taken on an annual basis is actually a percentage of the total coated rolls installed in a line. And considering 10 major steel mills, we got a total value for each scope, and the total value for 10 steel mill plants was coming. So that was when we were convinced that we actually have to do something to get at least a small chunk of this market. So when we received the order from JSW, we actually started this analysis and we tried to come with a solution. With the first solution being, what if we buy a new machine, which was not so feasible because of the involvement of the capital investment. Major hurdle also being the availability, because such huge size machines are not really normally manufactured it in India also, and also the commissioning time. Total time taken for procurement and commissioning was also very high. So that was not possible because we already have the order right now. So that was ruled out. Second being buying a second-hand machine, which was again ruled out because of the same concerns. The investment was slightly less, but again the turnaround time was very high. So these two options were scrapped out. Then we thought of upgrading the existing machinery. What if we can upgrade the existing machinery? For that, the first machine that we considered was a conventional lathe of having a turning die of 600 and a between center length of 5 meters. But again, in this machine, it was an Indian make and it was very roughly used for some other purposes. So the bed construction was not so rigid. The spindle was belt driven, which means it did not have the ability to take that load of higher turning cuts. The bed was excessively worn out. So scraping and trying to regain the geometric accuracy was again a big hurdle. That's when we moved on to the second option, which was the Innocenti lathe, and which was Italy made. Again, the turning diameter was around 600 the existing turning diameter, but the between center length was pretty nice. It was around 6 meters. And also, when we evaluated the other factors in terms of the construction of the machine, the rigidity, the spindle arrangement, and detail stock arrangement, we came to a conclusion that this machine was pretty much suitable for the type of work we wanted to do. So it had a good load carrying capacity. It had good arrangements for clamping and support. It had a positive locking arrangement, which is very essential when you are turning big size and heavy parts. The parts that we were thinking of machining are weighed around say 2 tons to 5 tons. So it is very important to have good clamping and good support. So thinking about these factors, we eventually decided to select this machine for the upgradation project. Before we moved on to the implementation part, we did a risk assessment wherein we jotted down few possible risks involved in the, which will come up in the implementation stage. First being the load carrying issue of the spindle drive. For that, the machine already had a gear driven type of a system with a metric 100 type of spindle taper bore, which ensured good support and clamping, and also it had good power in terms of it had a 40 HP spindle drive motor, so it had good power to rotate the job. Then disconnection of the X and Z axis feed drive was one more thing that we figured out, and it had an independent servo drive system, so it ensured that there are no other mistakes involved there. The third point being the slippage of the tailstock while turning. So this is what I mentioned earlier about the positive locking arrangement. So here you can see the arrow pointing near the tailstock. So it had this kind of arrangement which prevented it from sliding back, the tailstock sliding back because of excess load. The fourth point being the contamination of the spindle lubrication oil. For that, we are going to arrange inline filtration system for the spindle oil so that the contamination is avoided and the spindle runs for a longer time. Another risk identified being the lack of lubrication on the X and Z axis slide. For that, we thought of arranging a float switch along with this pressure switch arrangement so that whenever the oil level comes down, you get an automatic indication that you have to refill the oil. And also the pressure indication being that the lubrication is done evenly across the bed, because the length of the cross line and the bed is very large. So it's necessary to ensure that the entire bed is being lubricated properly. And the last point being the sudden jerking due to starting torque. So after being done with the risk assessment, we came to the implementation part. And the implementation part, we have bifurcated into mechanical and electrical section. Starting with the mechanical, we first dismantled the entire machine, the headstock and tailstock, because basically what we were going to do was to increase the size of the headstock, the tailstock, and the cross slide so that we can accommodate a bigger sized part. So for that, after dismantling, we took the sizes of the height piece. So basically, if you see the pointers here indicated by serial number 2, basically this is the height that we have increased for the headstock and tailstock and the cross slides. So we took the measurements so that we can give it to the casting vendor for making the castings. Parallelly, we were doing the machine scrapping and the spindle bush scrapping to regain the geometric accuracy of the machine. So that was also outsourced to a particular vendor. Then we did the servicing of the headstock, the tailstock, the gearbox, the feed and the apron gearbox. So we removed all the gears, did the servicing, refilled the oil. So all these things were done. Any worn out parts were replaced. We put in a new lubrication system for the spindle and the gearboxes. We put an inline filtration system for the spindle lubrication, like I mentioned earlier. We made a bigger size tank for the lubrication system so that the heat dissipation is properly done. There is no overheating of the oil while continuously the machine is running. There was an independent lubrication given for the apron gearbox, as you can see here down, 4 number. This is the apron gearbox. So we gave an independent system so that it is properly lubricated. And there was a centralized lubrication system given for the X and the Z axis slides, as you can see in the serial number 5. Coming to the electrical, so basically the whole idea was converting a conventional machine to a smart machine. Smart machine being basically there are multiple interlocks relating to the pressures, the oil levels, the faults, and even safety interlocks. So in terms of electrical automation, so you can see servo motors here, VFD here. So we had put a VFD to control the input torque of the machine. So we made a new electric panel and entirely changed the field wiring. All the wires were properly tagged, as you can see here. All wires were properly tagged and routed properly through cable trays. Servo motors were installed for the X and Z axis feed. PLC were installed for the interlocking. Here you can see the HMI. We made it very operator friendly. So basically, the operator has to just feed in the RPM and the feed to start the operation. So the dependency on the operator was also reduced. And we also tried to make it very maintenance friendly, so and operator friendly, of course. So we gave two operator panels since the machine was very bigger in size. One panel was given near the headstock, as you can see here in this image, and the other was given near the cross slide, where the operator will stand and operate the machine. We also gave a pendant, uh, which made it easy for the operator to set up the job on the machine. So usually when the part is being clamped on the machine, the operator has to be near the tailstock or the headstock to see whether the center of the job is in line with the center of the machine. So it becomes difficult for the operator to operate on the panel, go to the part, again come back, or maybe use multiple people while clamping the part. But with the help of the pendant, it was easier for the operator to actually manage that easily. We provided SMC connectors at multiple locations on the machine. So we had like junction boxes placed on on certain sections, and we provided this SMC connector so that it's easier for the maintenance guy to just disconnect that and do his work rather than taking out the entire wire, rechecking and rewiring and everything. So you can see coming to the implementation cost of the project. The entire machine dismantling and wiring was done in-house by our maintenance team. And the work of scraping and the manufacturing of the castings and the machining of the castings was outsourced to our vendors. The entire lubrication system, the mechanical material assembly, and the electrical BOM was also outsourced to vendors. And the total cost of the project came out to around 12.5 lakhs. This was the total investment put up in this project for the upgradation of the machine. So coming to the results of this project, the major impact that we had was we were able to do turning of parts up to 1500 mm diameter. And so also the geometrical accuracy of the machine was restored within 0.1 mm of the turning length. And we were able to do pre and post machining operations in-house on the same machine. We were able to eliminate the dependency of the outsourced vendors is what a major benefit that we got, because of that saving we were able to be more competitive in the market. We were also the machine was more operator friendly now, and it was more safe for the operator to operate the machine. I'll show a small video here in which you'll get a complete idea of how the actual operation is done on the machine. So here you can see the rolling machine. This is the pre-machining operation that you'll see. And I'll also show you a post-machining video where you'll get an idea of. So this was the roll that I mentioned. The JSW roll that we had told you on. The machine was commissioned completely. Video was taken. So moving forward with the savings, so in terms of electrical cost saving, based on the electrical consumption of the machine, we were able to calculate the running cost of the machine before and after upgradation. The working hours that you see here is actually the actual working hours considered for parts done between the effective period of 2017 to till date. So a total saving coming to about 1,31,000, only being the electrical saving of this particular case. Then giving a brief to you on the overall benefits in terms of PQCDSM. From the production point of view, we were able to do turning of bigger size parts. There were increased job opportunities because of the increase in the capability. Outsourcing was eliminated. Dependency of the operator was reduced. So we were able to use multiple operators on the same machine for different operations. Setup time was reduced because of the ergonomic design of the machine. In terms of quality, the taper was under control within 0.1 mm, the spindle runout and the axial play was within 0.0 mm maximum. And till date, there have been no reworks or rejections as such. Despite the operation not being so critical, but still there were no sudden plunging of the tool or any such cases that happened till now. Coming to the main aspect, the cost aspect. So here, because of this upgradation done, we were able to bag an order of around 93.17 lakhs of worth of rupees. And the increase in, so I'll just show you an Excel working the data which we had actually gathered for. So what we had done is, since 2017, since when the machine went online, till date, we have made a list of all the orders that we have done on this particular machine, with the size being more than 750 mm. And here we have calculated the cost of outsourcing this part. So here you can see, if the part was to be outsourced for pre-coating, post-coating, the transportation and everything, the total cost of per part would come to around this amount, including our own coating cost. But since we were doing this part in-house now on this machine, considering the electrical input and the labor cost, the in-house cost was coming to a much lower value. Here I have indicated the actual value of the part, and with that I was able to calculate the operating margin. So here you can see, if the part was outsourced, the operating margin was coming to around 34%. But since we are now doing it in-house, the operating margin is now significantly increasing, almost double of what we have been achieving. So here I have indicated the actual increase in the operating margin and the consequent cost saving done. We also have noted down the cycle time for each part, based on which we were able to calculate the electrical saving that I showed you earlier. Also, we have indicated the delivery timelines. So most of the parts were delivered on time, only one or two cases being where the part was slightly delayed due to certain circumstances. But all in all, if you see, coming back to the presentation, all in all, if you see a summary of what I showed you in the Excel sheet, there was an increase in the operating margin by around 17.75 lakhs till date. The savings in the setup time was around 0.95 lakhs, and the electrical saving, like I showed you earlier, was around 1.31 lakhs. So calculating the overall saving was coming to around 20 lakhs. So this 20 lakhs over a period of 4 years, which means there was around a saving of 5 lakhs per year, which if I compare with the investment cost, the ROI or the break-even period, if you see, comes to around 2.5 years. And the ROI margin, which basically is the difference between the total investment and the total saving, was around 7.52 lakhs. The OTD, on-time delivery status that I showed you, was around 85%. That was shown in the Excel sheet. Safety point of view, with the multiple interlocking and everything, the operation was more safer. There were no accidents happened in the last 4 years. Also, the operator morale was increased. It reduced operator fatigue. The design was more ergonomic, more operator friendly, and also he was able to do diagnosis of the faults by himself. Some additional benefits that I'd like to show: we got an appreciation letter from the JSW Ballari. We got multiple repeat orders from JSW after that. Also, we were able to execute orders for new customers like Siemens. So basically, we did many rotors for them, in which case the size of the rotor is very high. I mean, the diameter is very big. We did few hydraulic piston rods for Rufus India. We did for many rolls for CMI PE. The total value of these orders coming up to around 92.4 lakhs. So these were a few new projects that we were able to bag because of the automation done on the machine. Now coming to the horizontal deployment. So whatever we did in this particular machine, we were able to implement it in other machines as well. So we did a upgradation of a conventional lathe machine, and we did some retrofitting to convert it into a CNC. So we had converted this machine into a CNC turn mill. This being a grinding machine, in which again you can see the operator panel here, the main panel here. The similar method, similar interlocking we did on other machines as well to achieve the same, to get the same benefits. This is again a Russian conventional lathe machine that we upgraded, and this is a vertical turning lathe machine that we upgraded with a similar ideology. So this brings me to the end of our case study. I hope everyone liked it. And thank you for giving us the opportunity to present.